Tonight's kit build mistakes will be blamed on Night Owl La Shop Stout from La Shop Brasserie in Winnipeg. No real tasting notes on the can, however they do identify it as being a strong beer. But who needs their tasting notes? It's nice and roasty and dark malty and stuff like that, with a bit of a coffee overtone. I like it. So, month of December kit builds continues. Let's try this one. It's got a speaker in it, so I'm assuming it's supposed to make noise. Lots of component pins stuck to the magnet in the speaker. Of course there is. A couple of squashed chip sockets. Of course there is. Circuit boards, some LEDs, various things. Not too many components. Again, I chose all of these when I bought them as simple kits, so that's what we're doing. The good news is this one comes with a schematic. The bad news is it's very poorly printed and you can't read the component values and the numbers on them. But you can get a general idea of what's going on. It appears that we have a 556, which is two 555 timers in the same package. That's these two guys. Then we have some AND gates. Oh no, they got an inversion. They're NAND gates. 4 of those, probably all the same chip, because I think, yeah, we've only got 2 chips. So one of them's going to be the 556 and one of them's going to be a quad NAND gate. Okay, anyway, what can we tell? This, just like that alone, is the classic astable multivibrator, aka the standard free-running oscillator of a 555. And so is that. So we have 2 different oscillators. I think the component values are different on each one of them. That's 10K and 100K, that's 1K, and I can't read it. These 2 capacitors, one's an electrolytic, one's not, so they're going to be different values. So these 2 oscillators are running at different frequencies. Cool, that's fairly easy to understand. That's pretty standard stuff. Now then, these gates, let's see if we can figure out what happens here. This first one is just being, with the 2 inputs summed together, that's being used as an inverter. So whatever these 2 inputs are ANDed together, and if they're both the same, which they are, then it creates a high output, except for the inversion creates a low output. Being a low there, and the other side of this LED on the power rail, that one's going to turn on whenever the output of the oscillator is high. Then that also goes to here, to one of the inputs of this NAND gate, and its other one comes off of here, which is the reset line for both of these. Normally, for the oscillator to run, the reset line needs to be high. So if that's high, then whenever this is high, so basically this LED will be flipping opposite to this one. What is pulling that reset line? The other 2 NAND gates over here with a couple of switches to control them. Okay. The output of this oscillator goes to a transistor, and then it says SP. Speaker. Of course, we have a speaker in the kit. That's what drew me to it initially. Okay. So, and then there's a connection between the output of this guy and one of the inputs on this one, which I can't read. So, well, regardless, it's probably this one is going to be gating this one, I would expect. And then these 2 switches will be modifying, well, the reset pins, so should be stopping them, I'm guessing. Okay, so this guy's probably making a tone that the speaker can hear. This guy's flashing these 2 lights and causing this thing to start and stop oscillating as it's flashing. So this is probably a lower frequency, and this is probably a higher frequency. I wish I could read the component values, but like I said, this thing's poorly printed. But that's fine. We don't need to study the thing in too much depth. We'll just build it and find out what it does. How about that? So as usual, I'm starting with the resistors because they are physically lowest profile, and also they're the least likely to get damaged by my ham-fisted attempts at soldering and assembly here. I'll put in a couple of these resistors that are just individuals. They don't have another one like them. The rest of them all have a friend that is the same. So, for instance, there we have 1K. I'm just going to pull the tape off this time. The last couple of kits I have been cutting it off, and realistically, with relatively new components where the tape hasn't been on there for decades, they don't get that sticky. You're not going to gunk up the holes on the board that much. It's just as easy to do this way. What else we got here? Let's do these 100Ks. Where are they? One down there, one down there. So, as I said when I was looking at the schematic, I'm thinking that this is going to be some sort of a pulsed noisemaker with flashing lights. But I don't remember from however many months back I ordered these what I actually have in stock here. That's the beautiful thing about ordering stuff half a year to a year in advance when you're going to use it. You forget and you don't really know. It's like Christmas. What was this one? Oh no. Once again, yakking and not paying attention. What are you? 500 ohms. Okay. Or more likely, probably 510, which is what these two up here are. That makes sense. And after those two are in, that only leaves, I hope, 3 resistors left. 10K, 10K, and 10K. And I have 3 10K resistors. That's working out well. Comments from previous videos, somebody said I should be using a component bender that I could download and 3D print, like this one. I've had it for quite some time. I just keep forgetting to use it. However, that's the tightest that I can bend, and let's see how well that fits on there. That bend is too wide to go through the holes without jamming. So unfortunately for these tiny little resistors, that isn't really a super good option. But I'll do it to humor people anyway. That one's actually a little bit tighter. Maybe it's just one of those things where I need to develop a little bit more technique. That one dropped right in there. Okay, I'll use it for the final resistor. There we go. Where's that go? Up there. Right, now just a quick soldering. So I guess after resistors, the next thing I'll put in is capacitors. Let's start with the ceramic capacitors. Again, for the same reasons that I mentioned earlier, starting with the least likely to get damaged and abused. So we have 2 ceramic capacitors, a 104 and a 103, which are 10 nanofarad and 100 nanofarad. 10 and 100 there. Yeah, that looks like them. Nice and tiny in the middle there. Those would be a pain to put in after the chip sockets are in, so it is a good idea that we're putting them in at this juncture. Alright, now the 2 electrolytics that go down in this corner, 10 microfarad and 100 microfarad. What do we have here? That is the 100. The white band indicates the negative on here, and the positive is labeled on the board. Also has a little band where the negative side goes. This one I'm hoping is a 10 microfarad. Yeah, it says it's 10. Okay. Band for the negative. Good. There we go. So one of those is the timing capacitor for this half of the 556. And this one looks like it has an RC timing constant with this switch here. So when this switch is switched, this capacitor gets discharged at a certain rate. When that is open, then the capacitor recharges based on that resistor up there. So it'll be interesting to see what happens there. I'm assuming that, well, I don't know exactly. I'm assuming that when you turn that function on or off, whatever that particular switch does, it will, I said have a timing function. So what else do we have? I guess we have S1, K1, and K2. And in my pile of parts, there aren't any switches, but there are these 3 little suitcase jumpers. And there's some header pins, so I'm going to guess that those go together. So I will break off header pins. I'll never find those ones again. There, get a better grip on it this time. So I will break off some header pins and populate those into the 3 switch positions. S1 I'm going to assume is the power. And I think that's what it was labeled, or what it showed as on the schematic. K1 and K2 are going to be the controls. So we'll just have to see what those guys do. And as I usually do with little things like this that have a bad habit of falling out of the board until you solder them, I'm going to blob some blue tack on there just to temporarily hold them. And I could hold them with my fingers, but I will burn myself. I always burn myself. I don't want to burn myself. So we'll use blue tack, because blue tack is amazing. Of course, when you are soldering with blue tack, it does have a bad habit of getting soft and gunky, so just let it cool off a minute before you pull it off. And if you do get some residue, just sort of dab it on there and it'll pull it back off again. Nice. Chip sockets next, I guess. As is often the case with the chip sockets in these cheap, poorly packaged kits, they're horribly mangled. But that's okay. They're fairly, oh man, look at that one. They're fairly easy to straighten out just with a pair of pliers. I've broken a pin off that one. Well, that's disappointing. Fortunately, in my collection, I have some other sockets, so I will just use one of those instead. People often ask me in the mailbag videos, what do you do with all this stuff you buy? Well, what I do is I have an accumulation of spare parts handy for just this sort of a situation. I'll solder one corner pin, and then I'll reach around and push and remelt it, make sure it's in place. Then do the diagonally opposite corner pin. And again, reach around and push. There we go, a little bit of movement. You didn't see that, but I felt it. So now that socket is held. I can take the blue tack out of the way so I don't melt it. And then I can solder the rest of the pins down. And then just repeat with the other socket. This one is not nearly so damaged, so that's good. Hopefully it just drops in there and solders in just as easily as the first one did. Hopefully. Hello? There. Just needed a little bit of a nudge. Gentle persuasion. So next, we'll put in the LEDs. They look different to me, so I'm going to assume one of them's red and one of them's green. I'm also going to assume that it doesn't matter because it doesn't specify. However, the long leg is the positive leg. As you can see on the silk screen, that goes to the bottom. And again with this other one, long leg to the positive. There we go. And as you've heard me say before, I'll solder one leg down on each one. And then I will press them from the other side to make sure that they're nice and flat against the board. Remelt the solder. Get them right in place. Double check. Yeah, they look good. Then solder the second leg down. And we're good to go. I think I want to give this one just a touch more. There. There's no connector for the power input, so I'm just going to use another couple of header pins. Should be fine, I suppose. Oh, it doesn't fit the pitch of header pins. Okay, so since header pins won't fit, there are a couple of pieces of wire came with the kit, but I assume those are probably for the speaker. So what I'll do is I'll just use a couple of random bits of wire that I've got lying around here. That'll do. I'll use the white for the positive and the color for the negative, whatever that color happens to be. I guess I should mention for those of you who are new here, yeah, I am red-green colorblind, so I don't pay attention to color codes because they're meaningless to me. And when things are color-coded, I don't trust it because it's not a reliable source of information, so I always check with a meter. Now then, I guess, well, let's put the transistor in next. It is, let me just verify, yeah, 9014, just like it says. Excellent. So I am going to put him, actually, no, that's way too close to those speaker wires. Let's put the speaker wires on there first, and maybe, I think we should put the speaker wires on the speaker first. Am I supposed to solder wires onto that? I am very confused. Let's go into beeper mode. So that's a non-conductive silver paint on the back here. Well, maybe not completely non-conductive. Oh no, that's 8 ohms. Okay. Wow. Am I really supposed to solder onto that? Oh well, that's what they gave me in the kit. So let's just put some fresh solder on there and see if that works a little bit better. Okay, that's 8 ohms. All right. Not thrilled about this, but I'm going to go with it because that's what they gave me in the kit. Not super happy about this. Let's just test it and see. Okay, it works. I am completely surprised. Whatever. I guess that will do the job. Plus and minus for the speaker really doesn't matter in this case. Like, not at all. You can sort of see the wire still stuck in the hole where it's supposed to be. This is horrible technique. Don't do this. But it works. So is it really that bad? So the only thing left to solder on is that transistor. I already verified its right part number. Notice the flat side goes that way, the rounded side goes that way. Let's not make this mistake. So far, I don't think I've made any obvious mistakes in this kit, but then again, if the mistakes were obvious, then I would have already noticed them. It's the subtle ones that are going to bite me in the butt later. I think it's just plugging in the chips next, and yeah, they are kind of mushed in transit too. Let's just use this chip pin straightener that was gifted to me way back during my mailbag number 100. Thanks, Larry. It's the 556. Okay, so it goes there. Oh, that's kind of cool. The cutout in the center of the chip socket actually shows the silkscreen. Nicely done, guys. Anyway, the notch is on that end. You can still see the silkscreen, and I did actually put it the right way around for the socket. The notch is there, and this one has a dot on pin 1. So we can be fairly confident that everything's going in the right spot, I think. Let's make sure that's, yep, okay, good. None of the pins bent, good. And now the CD4011 quad NAND gate. Yeah, come on, get in there. Yeah, that looks like it happened. Okay, so this guy is officially built. Now I guess the only thing to do is see what it does. I'm just going to clean up some of this junk on here and I'll be right back. So 5 volts on the power supply, 50 milliamps. That should be a reasonable current limit. Power on. What's happening here? 10 milliamps. Okay, it's not in too bad a shape. Oh, okay. After some delay, or maybe when I touched it, it starts flashing those two LEDs alternatingly and making a really bad noise. Right, let's see what the two jumpers do. This is K1. Stops completely. Remove it. Nothing. Okay. Oh. And it starts again. Okay. Let's see what the jumper in K2 does. Absolutely nothing. Well, with K2 in, K1. Pull out K2 again, that stops it. Put it back in, it starts immediately. Pull out K1, no change. K2 out, okay. Interesting. I don't understand what that timing is all about, but and there it goes again. Wow. Okay. That's annoying. So let's look at this. I think that says 2. Okay, so that's K2 over there. So that pulls that gate. Okay, so do I have to figure out what these gates are doing? So K1 seems to be part of this. So I'm thinking that this timing capacitor here, yeah, because when we plug in K1, it takes a while and then it gets going, right? And K2 just makes it go immediately when you switch K1 on and off. So what it seems to be is, I guess, police lights flashing and siren, and you can start and stop it a couple of different ways. Weird. I suppose that's interesting enough. The tone that you're hearing will be coming from this one, and this one, in addition to flashing the LEDs, will be gating it on and off. What is that? Control voltage, maybe? If that's the case, then sending that high is going to change the point at which the oscillation happens. No, not the point at which it happens. The threshold of the high-low oscillation on this one, which will, I guess, change the frequency of it. Yeah, that makes sense, because that's what it's doing, right? Let's just turn this annoying thing back on again. And I'll plug in. Yeah, so that's 2 different frequencies. So that's what this line here is doing into the CV input. Shut up again. Okay. That's kind of clever, I guess. It's a horrible sounding square wave, but whatever. And all this is doing is starting and stopping it in a very complex way, I guess. Interesting enough. Kind of a cool circuit, I suppose. And it did accomplish my goal of being a nice, relaxing, simple kit to put together. And you'll notice that for the first time in this entire month of kit builds, I did not screw up once. I did not have one thing that I had to try and troubleshoot my own faults. So I'm getting better. Thanks for watching, everybody. I think I'll leave it on that note. Questions and comments down below. If I can find a link to where I bought this thing, I'm going to guess it's on AliExpress, but I don't know. If I find a link to it, I will put that down below as usual. Yeah, thanks for watching. I'll be back next Friday with another simple kit build, and that should wrap up the simple kit builds for December. I'll talk to you later.